Okay, I'll probably start in about 30 seconds or so. I think you guys can comment. Hopefully you can. Let me know if you cannot. Afternoon, Billy. Uh, if we can get at least half the class in, I should be good. Doubt everyone will show up. Afternoon, Hannah. Um, for everyone else on the stream, can you guys comment as well? Because I think it shows that there's four individuals online. Okay, Leighton's here. So I'm guessing the fourth person is probably Rod. Never mind. Yeah, we'll be up afterwards, Rod. Yeah. To be fair, today's lesson's not it's gonna be a lot shorter than the usual ones. It's just because we've done this before, but I'm just finishing the topic because we missed out a small bit at the end. Anywho, let's just start. So the key thing with diffraction gratings is we've done the practical before, where we shone light through a diffraction grating with like so many lines in it, and then after the light hits the screen, and then you guys get some patterns like so, right? And what we mentioned was, if you guys don't have notes on this, you can just draw it. But what we said was on the screen was that the middle fringe was always going to be what the zero order, so that's your main one. And then what we said is basically it's symmetrical. So you have your zero order, then you have the first order on either side, and then you have your second order on either side of the first, and so forth. So in the exam, they expect you guys to be able to label the different fringes. Yeah, and then these ones will be the second. So that's what you basically have. And they're all the same intensity. So they could try to trick you. Just remember that you mentioned that all the fringes have the same intensity because there is another practical where some are brighter than others. But for this one, they're all the same. Um, so that's very important. Okay, now with that in mind, and we've done a practical, we now need to look at how to find out the gap size. So if you look at the equation here, they do give it to you in the formula sheet, but they do not annotate it for you. So if you want to annotate it alongside myself, you can. So N just stands for the order number. And I'll do like one or two examples just to show you how we use it. So N is the order number. Lambda is obviously just the wavelength of light that goes through the grating. Now, you may or may not be thinking about what if we shone like white light through it, which is a mixture of different colors. If we do that, we cannot use this equation. Yeah, so this equation is only for monochromatic light. Equation is used for monochromatic light. So it's only one color. Yeah, that's why it has one wavelength. This is just the angle. Now, a lot of people get confused with the angle. The angle is always going to be between the zero order and then whichever other order you're looking at. So say we're looking for the second order, you'll put the number 2 in there, and then the angle for that would be between, there and then all the way to the second order there. That would have been that theta that you put in there. Similarly, if you were doing it for the first order, you put the number 1 there, but then the angle will only be between the middle and then there instead. Okay, now this part of the equation alone gets you 2 marks in the exam. This is basically gap size. Ah, I see. So we'll just look through what this actually means. Oh, this is a diffraction gratings, Keelan. We've done the practical in class. We're just going through the theory now. Um, so yeah. So this is the equation given, and we're just going to talk about how to find this part of the question. So let's look here very quickly. Oh, is it Callum? Whoops. No, my bad. All right, so this is a generic question. I kind of lied, there's 4 marks. So light enters a grating. They want you to find the wavelength. They give you this information there. So what we can do is, just very quickly, let's just write down the formula from there. So the formula is what? D sine theta. And Callum, this is given in the exam, so don't worry. So that's the formula. Now we do just write out everything we have. So we know that n is number 2, because it says the second order. And we know the angle, so theta is 38. Yeah, so we got them two. And we're trying to look for the wavelength. So obviously that means that we have to also know what D is, because you can only have one unknown. So let's find what D is. And what we mentioned was if you have a grating like so, I'll just make it have very few lines. This little d is basically the gap between any of the two gratings there. Yeah. So we're trying to find it. What they've told us was the grating has 600 lines in every single millimeter. So what we can say is 600 lines, what's it, in 1 millimeter. And in physics, we never work in millimeters. We always work in meters. So we will need to find out how many lines are actually in a meter instead. So what we'll say is in a meter, how many lines do we have? Now, a lot of people would just divide by 1,000, but it's all to do with the context. Here, what we're trying to say is in 1 millimeter, you have that many lines. So obviously, if you have a massive meter, you should have way more lines inside it, right? So actually, you'll have to times by 1,000 here because the meter is much bigger. So you end up with this and then just 1,000. Yeah, so you get this many lines per meter. Does this make sense to everyone so far? Because believe it or not, every single year, every single year in the exam, you get one of these questions, and you'll always get like a 4 marker based on this. Like always, is guaranteed. So it's very easy marks. Okay, that's good. So that's what we have. Okay, now this pretty much is still not little d when it was still not there. So what we need to do is we need to use this equation here. So basically, to find what this is, aka gap size, there's going to be 1 over lines per meter. They do not give you this in the exam. I do not think so. They give you this. Let me just double check very quickly while you guys write this down. So to find little d, just basically, do they give it? Nah, they do not give it. Yeah. So it's basically 1 over the lines per meter. We found the number of lines per meter there. So we got the denominator here. So if we do 1 over it, we can get what this little d is. So d would be 1 over this massive number there. And if you have a calculator, I think wait, let's see. So 1 divided by, okay, so it gives you 1.67 times 10 to the minus 6. Yeah, so that's what we get there. All right, now I think it's straightforward. So now you have what d is, you have what theta is, and you guys have what else do we have? What n is. So all you guys do is to find out what lambda is, pretty sure it's easy to rearrange, just d sine theta over n. Yeah, so you put this number times sine 38 divided by n. Oh, you mean on the calculator? Oh, this thing is so bad. On, damn it, never mind. It's too dark. You can't even see it. But you have to get what's it on a keyboard. Now I'm not too sure. I just copy paste from Google. But that's how you kind of work this question out. Okay, so congrats. This is the hardest question you'll get in in diffraction gratings. Actually, I lied. Never mind. But this is how you do this question. Let me show you another one now. Say you have the screen there again. Actually, damn it, never mind. Say you have a circular screen like this, right? And then let's say that you have your diffraction grating there again. You shine light. Obviously, we're going to get different fringes across, right? So if we exaggerate it. Now, the key thing is we know that this is the zero order. And then this is going to be 1, 1, 2, 2. I suggest you guys draw this. 3, 3. And if I kind of exaggerate the screen, make it like this. So say the light was shone from there. Let's say, oh, it's the actual dot. So the fringe is actual, these bright dots are the fringes. 4, 4. Let's say that basically you managed to reach 5 there, right? So with this circular screen, you managed to get 5 different orders by shining light through the grating. Now, the key thing is, looking at this equation again, d sine theta, this. Do you guys, just by looking at this, do you guys reckon we can hit maybe like a 10th order? So just judging by how... Oh, here it is, Callum. So judging by this, do you guys reckon we can hit a 10th order? So we hit 5, right? And say the screen is like that. Can we hit the 10th one? Based on that, just look at the intervals provided there. All right, that's good. So we definitely cannot hit it. Now, looking at theta, what's the maximum angle that we can basically achieve? Oh, an order is basically... Oh, I'll explain in a bit, Callum. An order is basically just each one of these dots from the center. So if I shine light there, it hits the middle. You got a nice straight line. That's always a zero order. Then you get other dots around. Yeah, it'll be 90, Billy, yeah. So the key thing is, guys, I hope you notice, so your orders can only reach a maximum of about there. It cannot pass where the light started from. That made sense. So if you look here, this is where we shone the light from. If you make another perpendicular line like that, this makes 90 degrees, right? So you can never hit more than sine 90, if that makes sense. So what they could ask you is, and this is the last question, what they could ask you is, what is maximum orders? And what they might tell you is basically lambda is 6 times 10 to the minus 7. They might tell you d is, 1.2 times 10 to the minus 5. And yeah, that's all they tell you. So this could be like a one marker, believe it or not, in the exam, or multiple choice. So looking at the equation, so d sine theta n lambda, what can we put instead of theta if we're trying to look for the maximum, number of orders? Hoping that you guys are thinking alongside the same lines as me. So d's there, times by sine 90, right? Because we said the maximum angles is 90, yeah. Or it gives you 1, yeah. And then we're trying to find the maximum orders, and you put the wavelength. And that's it, really. That's how you find n. So that's every single possible question, or every single possible numerical question you can get in this entire topic. No matter what they throw at you, it'll always just be this. To be fair, lots of people hate it. It's not the most popular question, but yeah. Yeah, Billy, yeah, it has to be sine 90. No, to find the maximum order, you have to put 90. Because that'll tell you what the maximum value is. So if you guys just put this in your calculator, what do you get? The reason why I need to get the answer is just to show you the last thing, because a lot of people might round it the wrong way for this. So I believe we get 20. Oh God, how the hell did we get just a whole number? Never mind. That is very annoying. I wanted to get a decimal place. Yeah. Okay, you know what? Let's assume it's so annoying. Let's assume our answer was this for whatever reason. So if you get 19.8 orders, would we basically round up to 20 or would we round down to 19? This way you get your last mark from, because obviously you can't have a decimal number of orders. So would you go up or down? All right, yeah, Callum got it. Yeah, never mind. I thought I could trick you guys. You always go downwards. Yeah, that's fine. You never go upwards. Yeah. So I just made up this number. So you go down. All right, yeah, you guys beat me. So that's pretty much everything to do with diffraction gratings. The last thing is they might always ask you, what's one use of diffraction gratings? So I'll give you two uses, and then you can choose which one you want to use. Yeah, perfect, Callum. Yeah, you cannot have part, because like you trying to say you only have part of a dot or one of the fringes. Well, we know all of them have to have the same intensity. They all need to be full. So one of them is basically we can use them in telescopes to explore distant stars. Because the thing is, when the light comes from different stars, it's the same as this practical here. When the light goes through the gratings in the telescope, further stars will have a different profile compared to closer ones. And then also you can use it in what do you use again? Oh, I can't spell that, but you can use it like in more advanced Polaroid filters. It's not the ones you put in your eyes, by the way, but yeah, you just let me think. Polaroid. Actually, you know what? Forget it. Just use this. Just have this one. I think this is the only one they might accept just because it's linked to astronomy, which is an actual topic. So yeah, that might have been in the old spec. That one. So just to explore distant stars. Yeah. So I mean, that's pretty much it. It's a dead easy topic, and the questions aren't that bad. So I guess what I'll do is on Friday we'll just do Young's double slit, which is a brand new topic. It's quite similar to be fair, just has a bit more maths and more theory. But yeah, so on Show My Homework, there's about I don't know like five multiple choice questions. If you guys can just do them and then let me know if you need any help with them, just by emailing me or like messaging me and Show My Homework. So yeah, that's pretty much the lesson done. Friday's one will be a bit longer, so I guess yeah. Hope you guys are surviving the lockdown. But I guess yeah, I'm done. Bye. Oh, which bit, Callum? Oh, you mean the very beginning? Oh, okay. That is fine. That is fine. What I'll do is let me do on a new page for you. It looks a bit messy there. Well, basically, if you remember the practical in class, so we had a screen like this. Okay, what on earth is happening? Sorry, don't know what I was trying to draw there. Imagine that's a screen. Then you have a diffraction grating. It's just like a tiny cube or cuboid that has so many lines inside it. And then we basically have the lasers, if you remember, that everyone's using in class. So you have a laser there, diffraction grating there. And when you shine the light through there, you basically get little dots appearing on the screen. Now, all the dots have the same intensity, which is very important. And they're all the same color because we are using monochromatic light. So if you remember from when we done waves, it just means it's like the same color. Yeah, perfect. It literally does that. So this basically proves that that photons also behave like waves because they diffract or they basically bend, and you get positions where they, what's it called? You get superposition, like where similar parts of the waves meet together. And then the darker bits, or the things with no light in the middle, is where they destructively interfere, where they cancel each other out. Kind of similar to standing waves, all waves in general, where they're constructive and destructive interference. What? Sundog? I guess. But that's yeah, so that's what happens. And so yeah, so you just need to know that all these dots have the same intensity, and you just need to know that the middle dot is always just known as the zero order. Oh, I'll need to check that out. I never really heard of it before. Yeah, so you got your zero order there, and then on each and opposite side, you have the first order, then you have the second order, and so forth. Yeah. Wait, how are you guys surviving the lockdown anyway? Did you guys start from boredom yet, or are you still having it? I don't know how Tom and Roger are gonna cope without putting things on fire. Ooh, I see. My condolences. uh, yeah, it's been tragic to be fair. Oh yeah, while everyone's still here, you know when what's it? When's our next lesson? Friday. I forgot what time I said. Was Friday 11 okay, or did you want it to be a bit later? Just let me know whatever time suits everyone. I think I said 11, right? I could do like 2 o'clock on a Friday if you want. Or was it 11:20? Okay, we'll just do 11. Oh, okay, that is actually good. Uh yeah, we'll just stick to the timetable. So it'll be like 11 o'clock. Oh yeah. Make it 11, not 11:20, because 11:20 is just awkward. Okie dokie. All right, guys. So I'll catch you on Friday. Just try the questions, and if you get stuck, just email me and then take a screenshot of whatever. Oh, for Friday, what we'll do is we'll spend about half an hour going through content. Then you guys do questions. Then I'll do the live stream again for the second hour, but I'll just go through the answers and that's it. Because we're at a position we're about 2 or 3 months early, so there's no point rushing through things. Or should I go to other page? And then just when you guys thought you can escape exams, what I'll do is probably after Easter I'll put like an online exam for you guys. Multiple choice. So yeah, that should work. But the most recent exams you guys done, that'll go towards your UCAS anyway. That combined with the one before it. All right. All right. Cheers, guys. Take care. Bye.